Okay, in this presentation we're going to look at how to convert from hexadecimal to octal. Now an important intermediate step is to convert from hexadecimal to binary and then from binary to octal. Now when you're converting from hexadecimal to binary, what we're going to do is use a little lookup table. Now we can actually express binary digits just with the just with one or two or three digits, with just what as necessary. But really, when you're working, particularly when you work with hexadecimal, it's best to express each corresponding binary number to four decimal places when you're doing these sort of conversions here. So even if you have, if it's 3, you will express it as 0011. Okay, 0011, and likewise. So we won't forget the two preceding zeros. Normally, 1 is the binary equivalent of 3, but in this case, we are going to use all four digits. You'll sort of see why shortly. So let's go to our question sheet here. So essentially what we have here is 4 hexadecimal numbers, and what we have to do is convert them from binary and then to octal. Okay, now really octal is the key thing here, but we have to use binary on the way. So the first number here with base 16 is the number 25F. So 2, the corresponding binary number there is 0010. I'm looking it up on that tables, okay? So you should actually have some sort of tables like that written out in your exam paper. Not the full thing, but just a little something to help you memorize it or look it up, and also demonstrate your workings. Okay, so I won't refer to it in this video, but you know it's there. Okay, in the background. Okay, so 5, that is 0101. Okay, and then F is 1111. Okay, now I have them sort of grouped here in groups of 4. Okay, but to convert to octal, what we're going to do is reconvert them into groups of 3. So we sort of start from the right hand side, okay, and then just regroup them into groups of 3. So 111 is our first group, then 011, okay, which is our second group. So that's that 0 and 1, and then that 1, okay. Then we have 001. That's our next group, and then finally 001. Okay. Now, essentially, just writing out those digits without the partitions or any of the coloring in, that's essentially the binary number here. Okay. Now, really, what we want is the octal number. So essentially, what we have here is we should have a certain amount of groups of 3 binary digits. Okay, so there should be 3 in each group. Okay, if you need to put in a 0 at the front to bring it up to a 3, do so. Okay, anyway, so essentially what we're going to do here is again use our tables to convert to the from the binary to octal. Okay, now in each case what we can do here is assume that there's a 0 in front of that. So 0001, the octal equivalent of that is 1. 0001, the octal equivalent of that is 1. And again, just pretend we have a 0 in front of that. 0011, the octal equivalent of that is 3. And then 0111, the octal equivalent of that is 7. So that means that in the hexadecimal number 25F to the base 16 has the octal equivalent of 1137 to the base 8. Okay, so that's the first of our group. The next one is 185 to the base 16. So in binary, 1 becomes 0001, 8 becomes 1000, and 5 becomes 0101. Again, we split them into groups of 3. Okay, so we have, starting from the right hand side, 101, then we have 000. Let's just double check that. That's that 3 there. Okay, and then we have 110 and then 000. These zeros here at the start. Now, essentially in this instance, what we can do here is just really ignore those 000, ignore that group, and just concentrate on this set here. Okay, that's set of 3 numbers. three sets of three numbers even. So 1, 0, 1, that gives us 5, 0, 0, 0, that gives us 0, and 1, 1, 0, that gives us 6. So 185 in base 16 is equal to 605 in base 8. So a little bit tougher again, AE0 to the base 16. So A becomes 1, 0, 1, 0. E becomes 1, 1, 1, 0, and 0 is 0, 0, 0, 0. Okay. That's, I didn't really mean to put it, it's not O. Oh, it's basically what I'm saying. I decided to put in a cross there just to emphasize it's a 0, but I think everyone gets the idea. Okay, so we have 12 digits there. Okay, so we're going to reorganize them into groups of 3, sort of favoring starting from the right hand side. 0, 0, 0, okay, 1, 0, 0, 0, 1, 1, and 1, 0, 1. Okay, so we get 5, 1, 0, 1 is 5, 0, 1, 1 gives us 3, 1, 1, 0 gives us 4, and 0, 0, 0 gives us 0. Okay, so AE0 to the base 16 should equal to 5, 3, 4, 0 to the base 8. And finally, one last one here. Convert the following hexadecimal number to binary and octal. So FBA to the base 16. So F is 1111, B is 1011, and A is 1010. Okay. So what we have, so essentially again, split them into groups of, they are in groups of 4, split them into groups of 3, okay, and sort of start from the right hand side. 101, okay, it's this group here. And 111 is that group there. Okay. 111. Oops, sorry, no, that is 110. I made a mess of that. Here we go. And then 111 out here. Okay. So it's just rearrange them into groups. Okay. So we have 111, which is 7, 110, which is 6, 111, which is 7, and 010 is equal to 2. So FBA to the base 16 is equal to 7672 to the base 8. Okay. Now, something I should just remark upon here is that I'm very explicit about the hexadecimal equivalent and the octal equivalent. Really, for the sake of propriety, and completion, I really should have put in something similar here just to specify this is this number in binary. Okay, so really in each of these ones here, I should have wrote out 1 1 1 1 1 0 1 1 1 0 1 0 to the base 2. Just to sort of, we were asked that just to make an explicit statement of that. Okay, I sort of skipped past it here because hexadecimal to octal is the real thing we're doing, but we were actually asked this in this question, so give an explicit answer. Okay, I was a little bit remiss about that in this video. It's partly just get through it quickly. Okay, we'll leave it there.